Good afternoon, everyone. My name is Robert Huber. I'm the Vice President of Global Portfolio Development for Digital Manufacturing. So basically responsible for the entire digital manufacturing portfolio from a go-to-market perspective. That includes manufacturing planning, manufacturing operations management. It includes data-driven manufacturing, which is one of the main topics today. It includes service lifecycle management and logistics. This topic, however, is one of my favorite topics because it really makes an impact in the way manufacturers work. I want to start a little bit with a customer that I have worked very closely with a few years ago and explain a little bit on what they have achieved and how they approach this and how solutions have changed and accelerate this process today. This was a Scandinavian contract manufacturer for electronics. They had a few sites around the world. They had one in China, one in Eastern Europe, one in Scandinavia. Most of the customers were Scandinavian customers, and we all know Scandinavia is not necessarily a low-cost country. So they wanted to bring manufacturing closer to the customers and still needed to be competitive. So they went on a journey. So their solution was to drive a continuous improvement program as an operational excellence program. And after 2 years that they embarked on this journey, they achieved a $14 million savings, recurring savings per year on the SMT line, a $1.3 million savings on a final assembly line, and overall became the lowest cost manufacturing site worldwide for this company. Now, why do I start with this little story here? Because I've been in manufacturing for more than 30 years. I've lived in the US, I lived in Asia, I lived in Europe. I've seen many, many customers around the world. And one thing they always had in common, each year they had to achieve a new target. They had to improve something. Either it was productivity or quality or on-time delivery or incidents or inventory turns. It just never stops. And you know what? When you set a target, I need to increase my productivity 7% for this year, and maybe after 11 months you even achieve it, what do? You lean back and say, that's it, finally done. Never. You say, okay, what shall we do next? Is it we increase more? 7% was not enough, or shall we go after another KPI? And once you optimized, all of a sudden a new technology comes in. Now in electronics, for instance, you have smaller components. And now the whole quality drops, the productivity may drop, and you have to start this process again. So how did this company do it? They selected a few KPIs, and I explain on a few KPIs what this means. The first one on your top left is the changeover times. I mean, this is a high-mix manufacturing. Changeover times was about 30 minutes. And you can imagine if you have, let's say, 10 changeovers a day for 30 minutes, that's 300 minutes. That is basically 5 hours that the lines don't produce. So this was very important to them. They knew benchmark was about 5 minutes. And so they set a target of about 5 minutes, and they started to optimize. Initially, the thinking was quite simple. Oh, I know how they do it. They have changeover tables, they have extra feeders. Let's order these additional assets. They went through procurement, ordered it. A few months later, it came, and all of a sudden, they reduced the changeover time from 30 minutes to 15, but they were not down yet at 5. And all of a sudden, they started to optimize. And the way they optimized is they looked into the shop floor. What happens here? Oh, why is the material so far away? Can we bring it closer to the line? Or why is there only one person doing a changeover? Can we not call the people from the repair station just a few minutes before the changeover and do a real pit stop? Basically saying, John, get ready. The last boat is in machine 1. It's coming out. Change. Follow to the next line. So organize it like at a Formula 1 pit stop. And as you can see, After about 17 months, they were down to 5 minutes. And the importance about this is it's not only a one-time thing, they were consistently down to 5 minutes. Now let's have a look at the different KPI, the defects per million opportunities on a screen printer process. That's one of the most error-prone process in electronics manufacturing, most complex. And you can see how the results were fluctuating. Now there is a saying that says, you cannot improve a process that's out of control. So the first thing they had to do is they had to bring the process in control. Took them about 18 weeks. And then they fine-tuned, they optimized, and it's so many parameters. It's the stencil, the solder base, the squeegee, the pressure, the speed, the design of the pads, the design of the stencil, the cut of the stencil, and so on. There's so many different parameters. And they try and error to see how they improve it, because there's no formula that says you use these parameters and it's going to be best. They're all documented, and it went up and down a little bit. Sometimes if it goes up, like you see it here, it may actually be that the machine needs maintenance. So there's some other overlaying factors. It's quite complex. But after about, 28 weeks, they were consistently down to less than 100 defects per million opportunities. Similarly, on the top right, you see the overall line effectiveness. They had about 40%. They set a target to 50. They improved it consistently. After about 8 months, they reached it. 2 months later, once they realized it's very consistent there, they decided, let's increase the target now to 60 and continue to grow it. And for the panels per hour, they didn't have a target, but they started with about 40 panels per hour when they went on the journey. 2 years later, they reached 120 panels per hour, which is basically one line could produce as much as initially they needed 3 lines for. And if you think about it, a line costs somewhere between 1 to 2 million, depending on how long it is, how much asset saving this is alone. Now, when we look into what these improvements are, the first one is primarily a workflow-related improvement on how you organize, how you do things, and so on. The second one is a process-related improvement. Of course, the asset maintenance and so on play a role. The third one is a combination of workflow, process, and asset-related topics. And the last question is basically, how can we accelerate these improvements? This company needed 2 years. How can we make it now faster? In 1 year, half a year, and so on. The process that they used is a Six Sigma process called DMAC: define, measure, analyze, improve, and control. And what we've done is we took this process and embedded it into our system. Because what we've seen is very often that our customers struggle to implement this. First of all, they don't always have all the data to measure it, and then you have the first thing, that is, the methodology very often is not known. They very often hire consultants and so on, but we'll talk about it in a little bit. So we embedded this, and we enriched it also with a co-pilot, and I will talk about this in a few minutes. I think you got a glimpse already from Bob Jones on this co-pilot, but I will drill down a little bit deeper on the real usage of it. We also created this framework, and just a few things to mention here is we collect direct data from the shop floor, but at the same time, we collect data from other systems like a MES, like a quality system, and so on. Because we bring those two data together to contextualize, and I will talk about how important contextualization is in a few slides as well. We created transparency, and we have several apps And this is only a snapshot, there are more than this, to help you address certain problems a little bit more efficiently. The other piece that's for us always important is when we talk about data-driven manufacturing, you collect data and you create value. So we always look into how we integrate our data. Insights Hub is our analytics platform. When you integrate it with an MES system, you tell the MES system that the main functionality is about process compliance. You turn it all of a sudden into a solution to help you achieve manufacturing excellence. Similar, when you embed it with a quality system, it changes the quality system from quality control to quality prediction that allows you to improve quality ahead of time. Similarly, when we do it, let's say, with a plant simulation, where we have created all these virtual simulation models, all of a sudden we are updating it with real-time data and becomes with real-time simulation model. So important for us is that we always enrich our applications that we also sell in our solution. Now, what we see very often is when I talk to customers on how they do this process, the continuous improvement process. Today, most of the customers do it with pen and paper or Excel and so on. They don't really have a system here, and they struggle. Often I see them hiring consultants, and you know what the consultants do? They're highly paid. They take stopwatches, they take time, they take files, they compile them, they try to create transparency for this improvement process, and they improve. But what we also very often see is once these consultants leave because the job is done, nobody takes the effort anymore to collect all this data, and the performance usually goes down. What we also hear, some customers say, no, we are a little bit ahead. We believe that we are now in a digitalization age. But when we ask them, so what do you do with the data? Many of them say, well, we just started to collect data, or we haven't started to analyze it yet. We don't even know where to start. Reality is, as long as you only collect data, you're only creating a jungle of data that's only cost. There is no value. And it's quite expensive. Right? You have to use the data. And one of the takeaways that I would like you to take away today is the statement that I make right here now is data without context is not knowledge, and knowledge without comprehension is not wisdom. And what we have done with our solution is we thought about this very hard, and we created a data contextualization engine to do exactly that, and we created a co-pilot that is able to comprehend all the knowledge that we have and create wisdom. And this is what I'm going to show you over the next few slides on how this will work. Again, when you start with this DMARC process, the first thing is to start with define. And I get very often questions, well, how you decide what to define? You always start with KPIs. Those are a few that were very important for manufacturing. I'm sure you have some additional ones, other ones. Not saying these are all complete, because every company is different. But if a KPI is not affected by an improvement that you want to do, why doing it? Right? So you have to select, you have to start monitor, you have to know your KPIs, you know what's the benchmark, what's good, what's your target. You have to set those and work around those. You need a system that gives you then the asset data for these KPIs, but also the MOM data, because you need to learn from it, and you need to have the framework that everything is integrated. And that's what we provide in our solution. When we talk about the improvements now, again, we spoke initially about a workflow improvement, Well, we have simulation tools today for workflows. Now, this is an industrial metaverse, right? It guides you through a factory. It's built on some of the tools like plant simulation, process simulate. You can see the flow of material through a factory. You can see how robots are acting. You can see the cycle time. You can validate the programs if they are correct, if they function the right way or are destroying something and hitting each other and so on. You can also check humans, how fast they are. Is it ergonomically for them? Is it safe for them and so on? Right? This is a much, much better and more efficient tool than in the past when people went to the shop floor, watched it, looked at it and tried to improve. They made some changes. The next day they came back and said, well, in the last 24 hours, did we improve? Shall we keep this change? Or did it get worse? Shall we go back to what it was yesterday? Now we can do all these simulation models in minutes instead of a long time. But this is data-driven manufacturing. So what if we take such an industrial metaverse? This is one of our factories in Erlangen, Siemens. So it's an industrial metaverse, but it's now enriched with real-time data and simulation data. So we can have both in it to actually simulate how things work. We can look into a certain cell, not just see how it behaves, but also what are the KPIs. We can go to a machine that has a problem. And again, you look into first on the KPIs to see whether it's okay or not, but then you can also look into time series data, events data, and so on. If you load time series data, you see maybe abnormality, and you need to troubleshoot what it is. And when we talk about real time, look, this is the real robot, this is the virtual robot. And when now the human comes, just have a look what happens to the virtual robot. This is what we call real time. All of a sudden, the simulation models are so much more accurate. They reflect really what happens there, and not just on a theoretical basis, actually on a real-time basis. When we talk about process and asset improvements, it's different. Here we show you a little video about a maintenance case. Okay, now it's starting. So this is a maintenance case where we analyze why the performance of a machine is actually dropping. We look into availability and see it's not very good. So we drill down and look into the time series and see at the end of the period, actually you have a little bit of a drop. You see a lot of red bars, which is downtime. So we do a downtime analysis and it tells us it's a drivetrain issue. We call maintenance and they confirm, yes, it's a drivetrain issue. The problem is they don't know why. Right? And they're searching and getting frustrated. I cannot figure out. It's randomly. Sometimes it happens, sometimes not. So we go into contextualization, check, is it always the same shift? Is it always the same product, always the same material? Oh, there was a high overlap in material. So we look into the material and see on a third material base, the vibration is higher. Now in this case, the maintenance team says, okay, it's higher, but it's not damaging anything. So they're increasing the threshold for this third material so the machine doesn't stop and it continues to run. But the point that I wanted to make is very often in life, it is that one data source cannot tell you the true story. It gives an indication. Yes, the machine stopped. Yes, it was vibrating. It's a drivetrain issue. But in order to find the reason, you need to be able to contextualize. You need to find correlations. What else happened at the same time? So this contextualization engine is very critical in the root cause analysis to accelerate this one. So when we then go to improve things, here I show you how a Copilot works. Again, this is okay, it's running now. Again, the typical way in the past was we see a line that's red, it has some issues. I click on it and I look what happened here. Right? So I look into the events, I see an error code, 06X whatever. I don't know what it is, maybe somebody knows or I need to look up in manual. That's our old way. But what if we change the way we work and I ask a Copilot, can you summarize the status of the line? Right? And it tells you, it analyzes it, and it gives you 3 areas. The first one tells you what's the equipment state. The second is what it recommends to do. And the third one is the source of the information. Why does it know this? Because it collects real-time data. You can also collect ad hoc data that's entered by people. It uploads manuals. It can also connect to MES data, and it has everything at the fingertips to come to this conclusion. And what's always important for us is, of course, I can now see the nozzles are dirty, and maybe I know how to do it, maybe not. If not, I just ask the Copilot how to do it. Now, it gives me real instruction because it reads the manual and writes it down here. Now, if I'm not sure if this is right, I can always click to the source of the information, and I see the manual. It jumps here, it gives me the instruction on what I need to do. It's much more efficient than everything else today. Now I'm saying, okay, I don't know how to do this. I want maintenance to do it for me. So I create an incident. Now it writes me the report for an incident. This is a much better quality than if you ask me to write it, because I just say Nestle is dirty and that's it. Here it gives all the background information. I can reread it. I can edit it if I want, or submit it. And then I quickly decide the urgency of it, and I'm done. But now my next question is there any delivery impacted? So I ask if there's the production schedule impacted, and it gives me yes, 4 of these orders will be late. And now I can tell the Copilot, okay, please bring me to the scheduling engine, because I want to see if there's something I can do, shift some sequences of other orders and so on. But this is a completely different way on how we today can work with the lines. It's really changing. We're in the beginning, but this is already quite amazing for me, how this works. So one of the hardest things is always the control area. For me, when we do continuous improvement, it's relatively easy to achieve a certain KPI once. But it's very hard to keeping this KPI on a consistent basis, regardless of who is working at the line. I may have some good people, I may have some people that we just hired from McDonald's next door that are being trained as an operator and so on. That's real life, right? Traditionally, we always used Excel. Of course, we have now data. That's quite simple. But what do? Important is when you improve a KPI, you need transparency. So for this, we have the dashboard designer. So we can go into the system, and the dashboard designer has created a dashboard already for structured and unstructured data. And I can see, I can link it, I can go to all my KPIs that I already have, can import them or just link to them, whatever I want. So it's quite flexible in what I want to do. But in this case, if I say I want to improve cycle time, every person in my factory that can influence the cycle time needs to see what it is. They all need to understand the impact of the work. So you select basically the machine that you want to have, or the line, or whatever it is. You select what kind of data. In this case, we say the cycle time data. You decide on how this will be shown, whether it's a bar chart or a line chart, or in this case, maybe a histogram is the ideal solution. You select it, you resize it, and you have now created transparency. Because it's important that people understand if they change something, if they improve something, maybe get worse or whatever, they need to understand the impact. And from here, of course, you can also imagine this is now one, let's say, operator that needs to work on it. I have a different operator that also may impact it. He has a different dashboard, and here you just add it in his. Important is, again, this is a tool that you as customers can use it. You don't have to hire somebody from Siemens and say, now I need to do this, because this is creating on a concept when you you have to be able to modify it. Now what happens after you have this been running for a few years? You may end up with 200 dashboards. We have, for instance, Siemens. They have created in the meantime somewhere between 200 to 300 dashboards. So what do? You look at all of them, you wouldn't see anything. It's too much. So once you have improved a KPI and it's consistently within the target, you move this KPI to the background. And it only appears when you violate it again. I think that's very important. Why is this important? Because you have improved, using these dashboards, the performance of the line, of the machine, of a KPI. You want to monitor it also in the background, so you don't go back. But you don't need to look at it every day, because you have improved the process, and it's now quite robust. But you never know. If a machine needs maintenance, then maybe you may violate a KPI again, as an example. Or if a material is bad from a supplier. I also want to show you a little bit on how this works now from an execution with bringing different systems together from Siemens.
Welcome to the world of smart manufacturing for electronics, where intelligent execution, AI-powered insights, and low-code agility converge to transform operations. Here, on the shop floor, we see Ops Center execution electronics in action, orchestrating operations through the bill of process and the 5 M's: man, machine, material, method, and metrics. Every step, every task is digital, setting the stage for real-time control and long-term optimization. This box build cell is one of many across the plant, each working on complex assemblies with precision and traceability. Meanwhile, in the operations office, Insights Hub provides a plant-wide view of performance, not just what's happening, but where improvements are possible. Through AI, the system detects throughput fluctuations, missed targets, or process instability, and proposes realistic, data-driven goals. We ask the Copilot AI, where is performance drifting? The AI responds with insights, targets, and recommended actions, all based on real historical data and proven patterns. But how do we bring these insights back to the people who need them most, the operators? Enter Mendix, Siemens low-code platform. In just a short time, a powerful on-screen app is built. It displays real-time throughput, compares actual versus target, shows stretch goals, and uses color indicators to guide action. As an example, operators can press a support button, record a short message, and send it directly to a mobile technician who responds with an ETA. Another button lets them log a deviation, voice-to-text enabled, fast, traceable, efficient. Now, back on the shop floor, both systems run side by side. MES executes the work. Mendix guides performance. AI feeds intelligence into both. This is data-driven manufacturing in action, where execution meets intelligence and insight becomes impact.
So this was now a little bit an example of how we actually work in our portfolio together to bring the solutions for the whole continuous improvement process together. It's not just one, it's an integrated solution because people use different tools on the shop floor. They don't want to switch applications and so on. So it all has to be integrated and make very efficient ways on how to drive the execution of this data. Now, so far we have looked into this continuous improvement process. And this was primarily, or actually only, the descriptive approach that we have seen. It's already amazing what we do here. We also have predictive analytics, and we will go a little bit into prescriptive also. Again, to explain a little bit what's the difference between descriptive, predictive, and prescriptive, I always use my example. When I go to a doctor, he looks at me and says, yes, I can already tell you didn't eat healthy, you don't do enough sports, So this is descriptive. He knows what he sees for me. Predictive is, he tells me, you need to watch out because overweight people have a risk of high blood pressure and cardiac issues and so on. But prescriptive, then he tells me, you know what, you need to change the diet, you need to exercise more and take these pills for the high blood pressure to prevent anything from happening. And similar in a factory, this is the same thing. Descriptive is looking into the past, into the history, and learning from it. Predictive is looking in the forecast. So we have some apps, for instance, the quality prediction, we have energy prediction, we have a generic prediction that we can use for different methods. And how this basically works on a very high level, I'm sure there are some other sessions that go into more details here. But we basically collect machine and process data, we feed an AI model, and we predict the quality and the defect reasons for it. Right? Why is this important? Because you have a multi-stage process. If I can predict the quality after step 2, there is no need to run a bad product through step 3 and step 4. Wasting machine time, creating more scrap, more expensive scrap, or rework, and so on. So with this we have customers save millions because they can actually, early enough in the process, decide whether it's good or bad, especially in some of the industries like battery, where you have to wait for the final quality results, so sometimes weeks. Right? So this is important when we go into predictive. Prescriptive, again, when you think about it, how do you get to prescriptive? Once you combine predictive with a co-pilot that we have that has all the knowledge combined to it, that's where we go into prescriptive. We are not quite there yet, but we are not far away. This will be the next stage that we do. Now, we had those 4 use cases at the beginning, primarily workflow-related topics, primarily process-related topics, primarily or a combination of workflow, process, and asset-related. And for here, we have basically industrial metaverse to address this one. We have the data contextualization for this kind of topics. We have the co-pilot for the other kind of topics. And really, what we do with all this solution is we accelerate the time for the improvements drastically here. Now, it's my last slide as a takeaway for today. Is continuous improvement never stops creating value. Because you improve something and then you go on the next journey. So you need a solution. If you only buy an app to solve one problem, once this problem is solved, this app has no more value. When you have a system that helps you continuously improve, it just never stops creating value. Now, Insights Hub allows you to drive the operational process of continuous improvement. We still require knowledgeable people on the side, what to do, what to change, how to improve, and so on. Not everything is given yet. Data contextualization is key because it turns data into knowledge, and the production co-pilot accelerates your journey to manufacturing excellence because it turns knowledge into wisdom. And with this, I would like you to point out a few of the other sessions that we have today and tomorrow over the next days, basically also Wednesday over there, from partners, from customers. We also have some sessions from Dr. Ralf Wagner here in the back. That follows right mine session now. And if you have any question, it's now the time to ask. Thank you. Any questions? Yes?
I have a question. So thank you very much. It was very interesting. You mentioned you had, I think, over 30 or 40 years of experience, and I'd like to see the DMAIC methodology. It was nice to see the DMAIC methodology. From your perspective, not everything needs to be probably solved with digital tools when it comes to continuous improvement. So
No.
Where do the traditional capabilities of DMAIC and continuous improvement end? And where do you start needing digital tools to really make that jump to the next level?
Yeah, you can do a lot without digital tools as well. I mean, the whole DMARC process existed for so many years, it still does today. But the way usually teams work in this process is, right, they get together once a day, they decide which KPI to improve, what to change, and then they implement this change. The next day they get together, and then they say, well, yesterday we made this change. Did we improve? Or did it get worse? If we improved, shall we keep this change? Did we reach the target? Do we need to further fine-tune? Right? All this works without digital. It works, I mean, sometimes with stopwatches or whatever, however you measure, right? It's a little bit more effort. When you have simulation tools, like I showed, for instance, I can do multiple iterations in minutes and so on. So whatever it took me days in the past, I'm much, much faster here. So it's an acceleration. Similarly for the process analytics, right? So we showed a little bit of data contextualization. That doesn't mean that without such tools you cannot figure out what it is, but it may take much, much longer. So I think where data really drives is the acceleration of it. The process itself works without digitalization, but the speed of the process, I think, is different.
Okay, thank you. And the second point then is around capabilities, because I mean, of course, when you bring together your people on shop floor, you say, okay, we're going to look at this problem. It's probably different than, okay, now we're going to simulate this problem. Probably different competencies and capabilities are needed. So how do you see the operator of the future in this context as an enabler to make that jump to a more efficient, even more efficient production environment?
There's so much innovation ongoing also for the operator itself. I mean, in the field of robotics, there's a lot of things ongoing, whether it's AGVs, whether it's humanoids and whatever. So there will be a difference wherever it makes sense. I mean, if you do small things, you don't need to have a humanoid. You can have a hand robot or a human, right? But if you have whatever for cars to pick up something heavy and move it to the car, maybe a humanoid is better and things like this. So the world will anyway change there, right? The question is, what better tools can we give the people to do a better job, make it less strenuous also on the body and things like this? That's important, right? But the other thing is what I very often get asked a question, so I'll bring it up myself, is people always say, how do you get started? I mean, I have a big factory, I have whatever, 6,000 machines there. Do I connect them all before I get started with this process? The answer is no, right? Don't go on a journey and say, I connect now first before I start on a journey. I connect all the equipment, collect all the data that I do. It's usually you do it progressively. You look into an area where we think you need to improve. That's where we start the connection. Once you have the machine connected and analyzed, you keep it running, right? But to give you an idea, at the Siemens factory in Bad Neustadt that I mentioned earlier, had a nice conversation with them. They came to me and explained to me, you know what, one day production came to me and said, energy consumption was higher than usual. We don't know why. So the IT team said then, well, let's connect to the high energy consuming equipment and measure it. And they found one machine was consuming much more than similar machines. And because they knew that, they found a leakage. Now you have connected it, they keep monitoring it, and if it goes beyond the threshold, it will alarm again, right? But now you keep it. But this is not something you would do on day one unless you have a feeling, I have some energy issues. Other questions?
Yeah, hi Robert, I have one question.
Yeah?
Thank you for the presentation, it was really very nice. Just wanted to know, you have shown using digital twin, MES and Copilot together. So can we use Copilot separately without using digital twin or MES?
Yes.
Will it help? Will it give some solutions?
Yes, you can use the Copilot because it's based on data. But if you, for instance, don't connect it with the MES data, it cannot do the contextualization itself. It has limited knowledge, of course. But for the data that it has, of course, it can drive it. Whatever data it has, it can do it. If you upload manuals, it can read them. If you don't upload them, it wouldn't know. The more you give it, I mean, a Copilot computers, they are fantastic in processing a lot of data, much better than humans, right? So why would we limit it? That's the question.
Thank you.
More questions? No? Then you can always come to us and speak to us. Dr. Ralf Wagner is here in the back. He's the head of the whole Insights Hub team. And I'm here also at the show, so thanks for your attention here.